Today, we're going to discuss non-homogeneous systems of differential equations. This is a homogeneous system. We already know how to solve these, and in order to solve this system of differential equations, we isolate the coefficients matrix, find the eigenvalues, find the eigenvectors, and then solve. And then the solution would be x equals c1 v1 e to the lambda 1t plus c2 v2 e to the lambda 2t, regardless of what kind of eigenvalues there are. Okay, the solution of this system here, we're going to call it x sub c, complementary solution. Okay, what if there were additional terms? For example, we could add e to the power minus 3t plus t squared, assuming lambda 1 is not minus 3, and then here we could add, let's say, sine t. Well, the system becomes non-homogeneous, and when you're solving a non-homogeneous system, first you need to solve the homogeneous part. That means remove these, solve, and you get x sub c. We did this before. And then we need a particular integral, a particular xp. For xp, the form of xp, we can use undetermined coefficients for the form of xp. The form of xp should be the same thing as what we have on the right side. On the right side, we have a quadratic, we have an exponential, and a sine. We need to combine all of them. So xp would be a t squared plus bt plus c. This is from the quadratic part. From the exponential plus g e to the power minus 3t. And then the sine will lead to two more terms with sine and cosine, plus h sine t plus k cosine t. And guess what? The good news is you need to do this for both x and y. So we're going to have a t squared plus bt plus c plus g e to the minus 3t plus h sine t plus k cos t. These constants don't have to be the same, so we'll call the constants in the upper line, we'll use subscripts. One for them, a1, b1, c1, g1, h1, k1. And then these 2, 2, 2, 2, 2, and 2. So we have 1, 2, 3, 4, 5, 6, 12 constants to determine. Substitute both of these back into each DE, and you will end up with 12 equations and 12 unknowns, and solve for those 12 unknowns. Once you find them, put them back in here, and that will be your particular solution. We're going to do an example. I'm going to use a different additional term in each of these equations for the example. All right. I put 3t minus 5 in the first line and 2t minus 3 in the second equation. In the second equation, if we only had minus 3, let's say, even if we didn't have the 2t, our particular integral would still be linear. So it will be at plus b, ct plus g. Both of them are the same. Even if we didn't have anything in the second equation, our particular integral would still be like this. So small x is at plus b. Small y is ct plus g. We need to substitute for these in the original system of differential equations. Okay, dx dt equals a. dy dt, derivative of y with respect to t, is c. And x in this case is xp, and y is also yp. And dx dt is going to go on the left side of this equation. dy dt is going to go on the left side of the second equation. What do we put on the right side? Okay, you put 2 times x, which is 2 times all of this, plus 3 times all of this, plus 3t minus 5. So I'm gonna write this as equals 2x plus 3y plus 3t minus 5. And this is a equals 2 times x. X is at plus b plus 3 times y. Y is ct plus g plus 3t minus 5. The second equation is dy dt, which is equal to c. That should equal 3x plus 2y plus 2t minus 3. 3x plus 2y. So c equals 3x plus 2y plus 2t minus 3. And for x, I'm going to put in at plus b. And for y, ct plus g. Let's look at these two equations here. We have four unknowns, a, b, c, g. And we have two equations here that we can get four equations from. What we need to do is simplify the right side and the left side. So the left side is 0t plus a, I'll use a different color, okay, the right side is 2at plus 2b plus 3ct plus 3g plus 3t minus 5. Combine the terms that have t in them. That's this one, and this one. That's 2a, factor out a t, 2a plus 3c plus 3 times t, plus 2b plus 3g minus 5. I put the terms that don't have t in green and the terms that do in red. On the left side, I only had a, so it's 0t plus a. So the next thing we're going to do is identify the coefficient of t on the right side, which is 2a plus 3c plus 3. And that should equal the coefficient of t on the left side, which is 0. The constant coefficient is 2b plus 3g minus 5, 2b plus 3g minus 5. The constant coefficient on the left side is a. So now I have two equations. I got both of those from the first equation, from the dx dt equation. I'm going to do the same thing to the dy dt, which is this equation. So isolate the t, factor it out, and then I'll get back to the video. The second equation is c equals 3at plus 3b plus 2ct plus 2g plus 2t minus 3. Combine the terms that have t in them. So 3a plus 2c plus 2. 3a plus 2c plus 2 times t plus 3b plus 2g minus 3. The coefficient of t on the left side is 0 because the derivative of y with respect to t was c. Here's why. The derivative of y with respect to t is just c plus 0. So 0 should equal 3a plus 2c plus 2. That should equal 0. And then c is equal to 3b plus 2g minus 3. So I'll write those down here. So 3a plus 2c plus 2 should equal 0. And then 3b plus 2g minus 3 should equal c. 3b plus 2g minus 3 should equal c. So now I have four equations and four unknowns. Well, we can solve two of them at a time. Okay, the first equation and the third equation have only a and c. The second equation and the fourth one have only b and g. So we can solve two systems of two equations, which is easier than solving one system of four equations in four unknowns. So this equation here and this one can be solved for a and c. The second equation and the fourth can be solved for b and g. And I'm going to solve them. After you solve these two equations for a and c, you end up with a equals 0 and c equals minus 1. And then after you solve equations 2 and 4 for b and g, then you end up with this b and this g. Let's go back to what xp was. Xp, the particular integral was at plus b ct plus g. So the particular integral would be 0 minus 4/5 minus 1 times t plus 11/5. And this is the particular integral of this non-homogeneous system of differential equations. Well, we're actually done with the particular integral, we're done with the problem, but they didn't ask us to solve for the complementary function. As a bonus, let's think of this as over time, and let's solve for it. So you remove 3t minus 5 and 2t minus 3 and you solve the rest. The coefficients matrix is 2, 3, 3, 2. The characteristic equation is 2 minus lambda, 3, 3, 2 minus lambda, you set it equal to 0. So this is what you end up with. 2 minus lambda squared minus 9 equals 0. And it simplifies to this. And the two eigenvalues are lambda 1 equals 5 and lambda 2 equals 1. Here they are. Now we need to find the eigenvectors. So let's do lambda equals 5. For lambda equals 5, 2 minus 5, 3. 2 minus 5, 3, we don't need the second line, times xy equals 0. So this is minus 3x plus 3y equals 0, which means 3y equals 3x, so y equals x. Pick x equals 1, y equals 1. So your first eigenvector is 1, 1. For the second eigenvector, lambda 2 equals minus 1, put minus 1 in there, so it's 2 minus negative 1, and again you don't need the second line. X plus 3y equals 0, so this looks like 3x plus 3y equals 0, so y equals negative x. Pick x equals 1, y equals negative 1. 1, negative 1. That's the eigenvalue, that's the eigenvector. So xc is going to be c1 times 1, 1 e to the 5t plus c2 times 1, negative 1 e to the minus t. This is the complementary function. And the overall solution of the system would be xc plus xp. So it would be c1, 1, 1 e to the 5t plus c2, 1 minus 1 e to the minus t, plus what we got earlier, which is minus 4/5. And here I have minus t plus 11 over 5. This is the complete solution of this system of differential equations. It includes the complementary function, which is this part here, and the particular integral.